Trigonometry, the Pythagorean Theorem. About me. My name is Nikhil Vudityala, and I'm a freshman at Prospect High School in Saratoga, California. My hobbies include piano, soccer, and mathematics. My favorite subjects in school are math and English. Course details. In this course, we will learn what is the Pythagorean Theorem and where does it come from. I will also present you with some example problems about this subject. Course description. This is a very important and engaging topic in mathematics which students find really amusing. It helps students in higher math levels such as trigonometry. This lesson will help students learn where the Pythagorean theorem comes from and how to use it in different situations. Introduction. What is the Pythagorean theorem? Obviously, the Pythagorean theorem is a squared plus b squared is equal to c squared, where each letter represents a positive integer. But in this course, we will learn where it comes from and how to apply it to problems. What is the Pythagorean theorem used for and why is it important? The Pythagorean theorem is mostly used in situations in right triangles and is very helpful in trigonometry. Where does the Pythagorean theorem come from? The Pythagorean theorem is always applied in a right triangle. A right triangle is a triangle where one angle is 90 degrees. The side opposite to the right triangle is the largest side, and we call this the hypotenuse. In the Pythagorean theorem, the hypotenuse is labeled as side C. Proving the Pythagorean theorem. Imagine you have four identical right triangles with sides A and B as the legs and side C as the hypotenuse. Now you have to arrange these triangles so they form a tilted square in the middle. What is the area of this square? With all of its sides being C. It would be C squared, right? Now you would again arrange these triangles so they form rectangles inside the large square. Now you have two smaller squares inside of the larger square. Now the area inside the square hasn't changed, so that means the area of these two squares should be equal to the c squared. So what is the area of these two squares? So we have a squared plus b squared. So therefore, a squared plus b squared is equal to c squared, therefore proving the Pythagorean theorem. Example number 1. Find c, or the hypotenuse, using the Pythagorean theorem. So what would you do here? First, you would plug in the problem into the equation. A squared plus b squared is equal to c squared. A and b are 4 and 3, but they could be interchangeable. And c is c, so you would have 3 squared plus 4 squared is equal to c squared. Now add the squares of a and b. You would get 9 plus 16 is equal to c squared. So then you have 25 is equal to c squared, and to find c you would have to take the square root of both sides. Therefore, you have c is equal to 5. That wasn't so hard, was it? Example number 2. Find c using the Pythagorean theorem. Once again, we have to find the hypotenuse. Once again, you would have to plug it into the equation. A squared plus b squared is equal to c squared. C squared is equal to 8 squared plus 6 squared. So c squared is equal to 64 plus 36. Therefore, c squared is equal to 100, and you would have to take the square root of both sides. So c is equal to the square root of the 100. So therefore, c is equal to 10. Example number 3. Find a using the Pythagorean theorem. Now this time we are not finding the hypotenuse. We have to find a leg. So once again, we would plug it into the Pythagorean theorem. A squared plus 5 squared is equal to 13 squared. So now this is different. You have to subtract to the other side. So now a squared is equal to 13 squared minus 5 squared. So you had to isolate the a squared. So now you have a squared is equal to 144, and once again, you have to take the square root of both sides, so you get a is equal to square root of 144. And now you get a is equal to 12. Example number 4. Now we have a word problem. To wash a window that is 12 feet off the ground, Ronald leads a 20-foot ladder against the side of the building. To reach the window, how far away from the building should Ronald place the base of the ladder? So I've drawn a diagram here of the problem. So he leans a 20-foot ladder against the side of the building, and the building and the window is 12 feet off the ground. And now we have to find out how far is the base of the ladder from the building. So that's side X. You could take that as side A or side B too. So now you have to substitute it into the equation once again. So you have 12 squared plus x squared is equal to 20 squared. So what you have to do is isolate the x squared so you can find the length. So you have x squared is equal to 20 squared minus 12 squared. And then x squared is equal to 256. So now you take the square root of both sides, and you get x is equal to the square root of 256. Therefore, x is equal to 16. But you can't forget feet, the unit. The last example is example number 5. Ryan drove 3 miles east and 6 miles north. How far is he from his starting point? So, once again, I've drawn a diagram of this problem. He's driven 3 miles east and 6 miles north. So how far is he from his starting point? So once again, you have to substitute it into his equation. So you have 6 squared plus 3 squared is equal to x squared. And once again, you're finding the hypotenuse. 36 plus 9 is equal to x squared. So therefore, you have x is equal to 45 squared. So what do you do now? You take the square root of both sides once again. But the square root of 45 is not a perfect square. So you could either leave it as x is equal to square root of 45, or write x is about 6.71, which is the square root, approximately the square root of 45. Finally, I have one tip for everyone. It is a good habit to remember the Pythagorean triples so it can be easier to identify right triangles. What are the Pythagorean triples? They're basically integers that go together in the Pythagorean theorem. So 3, 4, and 5. We had that as an example before. So 3 squared plus 4 squared is equal to 5 squared. Is that true? 9 plus 16 is equal to 25. That's correct. Now let's try 6, 8, and 10. So you have 36 plus 64 is equal to 100. Is that correct? Yeah, that is correct. This can be a very good tip to remember when you're solving problems about the Pythagorean theorem. That's all for me. Thank you. Okay, so now we will move on to real-life applications of the Pythagorean theorem. Example number 6. Mount Everest, a mountain in the Himalayas, is about 8.5 kilometers tall. The Eiffel Tower in Paris, France, is about 1 kilometer tall. The distance between the base of the Eiffel Tower and the base of Mount Everest is about 7,300 kilometers. Find the distance from the peak of Mount Everest to the base of the Eiffel Tower. So here is my diagram. So we have the Eiffel Tower over here, and we have Mount Everest right here. We learned that the distance from the base of the Eiffel Tower to the base of Mount Everest is about 7,300 kilometers. And we also know that the height of the Eiffel Tower is about 1 kilometer, and the height of Mount Everest is about 8.5 kilometers. So the question was asking us, what's the distance from the base of the Eiffel Tower all the way to the peak of Mount Everest? So this value over here is x. So what you would do is substitute into the equation. You would have 7,300 squared plus 8.5 squared is equal to x squared, according to the Pythagorean theorem. A squared plus b squared is equal to c squared. Then you get this number right here is equal to x squared, and you can use a calculator for this, obviously, and then take the square root of that number, and that's equal to x. So x is about 7,300 kilometers. Our next example says, the tallest building in Brooklyn is Brooklyn Point. One of the tallest buildings in New York City is the Empire State Building. Brooklyn Point is 720 feet tall. The Empire State Building is 1,250 feet tall. The distance from the peak of Brooklyn Point to the base of the Empire State Building is 12.3 miles. What is the distance from the base of the Empire State Building to the base of Brooklyn Point in feet? So one thing you have to remember here is that it says 12.3 miles. So this is my diagram. You have the Empire State Building over here, and you have Brooklyn Point over here. So it said the Empire State Building is 1,250 feet tall, and Brooklyn Point is 720 feet tall. And it said from the base of the Empire State Building to the peak of Brooklyn Point, the distance is 12.3 miles. So we're trying to find the distance from the base of the Empire State Building to the base of Brooklyn Point, and that value is x. So we are trying to find a leg here, which would be A or B, because we already know the hypotenuse and another leg. So what we would do here is substitute into the equation once again. But just to make it easier, you would want to make everything the same units. So you would want to convert the miles into feet. So you get 12.3 miles is equal to 64,944 feet. And then now you use the Pythagorean theorem. 64,944 squared minus 670 squared is equal to x squared. And this would also require a calculator once again. And then x squared is equal to this number right here. And then once again you would take the square root of this number to get x. So x is about 64,941 feet. And as it said in the question, you have to put your answer in feet. So it was good to do this. Example number 8. Lightning struck a tree, causing it to break and crash to the ground. The tree broke off 12 feet above the ground, and the broken part was 20 feet long. If a broken tree formed as a right triangle, could we be able to determine how far away from the tip of the tree fallen is? So this is my diagram. So you have a right angle here. The tree was broken, so you have 12 feet here and 20 feet here. And you're trying to find this distance right here, which is x. And you can see that there's a right triangle right here. So what you would do is substitute into equations. And I guess you could see that as a pattern through all of these problems right now. So 20 squared, which is the hypotenuse, minus 12 squared is equal to x squared. So that means 256 is equal to x squared. So you take the square root of both sides. The square root of 256 is equal to x. So x is equal to 16 feet. Always remember to write your units at the end of your problems, whether it's a word problem or it's just a normal triangle. Example number 9. A Major League Baseball field has base lengths of 90 feet. How long is it from the home plate to the second base? This might seem like a simple problem, but it's more difficult than you think. So this is my diagram. You have a baseball field, baseball diamond, where each length right here is 90 feet. So this is home plate, first plate, second plate, and third plate. So we're just supposed to find this length, C, which is home plate to second plate. So what you would do is substitute into the equation, obviously. So you have to find this length here, right? So you see there's a triangle right here, a right triangle. So there would be a right angle right here. So a squared plus b squared is equal to c squared. So you would have 90 squared plus 90 squared is equal to c squared if you want to apply the Pythagorean theorem. So 8100 plus 8100 is equal to 16,200, and 16,200 is equal to c squared. So you would have to take the square root of both sides, so you would get c is equal to square root of 16,200. So c is about 127.3 feet. This is the last example. Example 10, real life application. The width of a soccer field is 60 yards. The length of a soccer field is 110 yards. What is the diagonal length of the soccer field? This question is very straightforward. So we have our soccer field here. The length is 110 yards. The width is 60 yards. So what is the diagonal length? So obviously you can see that there's a right triangle right here, or right here. So 110 yards, the legs are 110 yards and 60 yards. And now we have to find x. So what you would do is substitute into the equation. So you would have 110 squared plus 60 squared is equal to x squared. So x is about the square root. X is equal to the square root of 15,700. So x squared is equal to 15,700. So that means x is about 125.3 yards.